In this video, we'll study random variable and probability distributions. Now we already know once we conduct a random experiment, we get a set of all possible outcomes and we call this set as S, and this set is called as sample space. Say for example, we toss 3 coins. Now if we toss 3 coins, then for each coin we have 2 choices, either head or tail. So it will be 2 into 2 into 2, and that is total 8 outcomes. So if we write the sample space, this sample space will be HHH, HHT, HTH, HTT, THH, THT, TTHN, TTNT. So these are all possible outcomes when we toss 3 coins. And if we take another example, suppose we roll a pair of dice. Now, if we roll a pair of dice, we have 6 into 6, 36 choices. Now in this case, this sample space will contain 36 sample points, and they are 1, 1, 1, 2, 1, 6, 2, 1, 2, 2, up to 2, 6, and 6, 1, 6, 2, up to 6, 6. So generally speaking, if we have discrete sample space with finite values, say this S, which contains sample points x1, x2 up to xn, then this random variable x, it is a function defined from S to R, and this function, it maps sample points with some real number. So basically this term random variable, it is a misnomer because it is not a variable, it is actually a function. So a random variable is actually a function which associates sample points to some real number. Now say for example, if we consider our first random experiment and say this random experiment is E1, then for E1, we are tossing 3 coins and we are having these 8 possible outcomes. In this experiment, I can define a function x, and we define this x as number of heads. Now since we are tossing 3 coins, it can have either 0 head, 1 head, 2 head or 3 heads. So in this case, this function x, which we call random variable, will take 4 values. So this x, it can be 0, which is the case of no head. X could be 1, x could be 2, or x could be 3. Now when x is 0, it means from these 3 coins, we do not get any head. So this value of random variable, it corresponds to this outcome. So it corresponds to outcome TTNT. Now x is 1, that means one of them is head. Now one head, it is this HTT, THT and TTH. So this x equal to 1, it corresponds to these 3 points, HTT, THT and TTH. Now when we say x equals to, we'll have 2 heads. So this one and this one. So again, it will correspond to 3 sample points. So this is HHT, HTH and THH. And finally we have x equals 3. X equals 3 means 3 heads. So all 3 heads is this case. This is H, H and H. So basically this function x, what it has done is, it has mapped sample points with some real numbers. And this is how we define a random variable. Now for the same experiment, we can define another random variable, which is y. And suppose y is mod of difference between number of heads and number of tails. Now for this case, what are the possible values of y? Now in this case, y, it cannot be 0 because number of heads, it cannot be equal to number of tail. So y obviously is going to start with 1. Now it cannot take the value 2 because 2 has to be 3 minus 1 and 3 minus 1 is not possible. Or it can have this value 3. So in this case, this random variable y, it can take only two values, 1 and 3. Now y equals 1, it corresponds to 2 heads, 1 tail, or 1 head, 2 tails. So it will be this HHT, HTH, HTT, THH, THT, and TTH. And if we say y equals 3, it will correspond to all 3 heads or all 3 tails. So it will be this HHH and TT and T. So this is how we define a random variable. So basically a random variable is a function which maps sample points with real numbers. Now if we take this second random experiment, say E2, then here we have rolled a pair of dice. Now in this random experiment, one of the random variable we can define is sum of numbers on upper faces. Sum of numbers on upper faces. Now, what are the possible values for this random variable in this case? Now, minimum sum, it will be 2. And then it'll be 3, 4, 5. And maximum sum is 12. So in this case, random variable x, it can take the value from 2 to 12. Another random variable that we can define in this case is, say, this y. And this y, it corresponds to number of odd numbers. Now in any throw, either we can have both even or one even, one odd, or it will be both odd. So in this case, this random variable y, it can take values 0, 1 and 2. Now this is very basic introduction of random variables, just to have a feel of what random variables are. Now random variables satisfy one more condition, and that condition is sum of probabilities of values of all the random variable, it must be equal to 1. So if we take probability of all the random variables and we add them, then that sum, it must be equated to 1. Now once we have a random experiment and we have defined a random variable, what we can do is we can always create a table writing values of random variable and their corresponding probabilities. Say for example, suppose we take this random experiment even, which is tossing 3 coins. Now let us take this random variable x. Now in this case, this x represents number of heads. Now x can take 4 values, 0, 1, 2 and 3. So what we'll do is, we'll draw this table. Here we're going to write random variable x and it can take 4 values 0, 1, 2 and 3, and here we're going to write their corresponding probabilities. Now what is the probability of x equals 0? So we'll get x equal to 0 when we have tt and t. Now what is the probability of getting tt and t? So in this case, favorable outcome is 1 and total outcomes is 8. So this probability is 1 by 8. Now what about x equal to 1? For x equal to 1, we have 3 favorable outcomes. So it will be this 3 by 8. For 2 also, it will be 3 by 8. And for 3 heads, it will again be 1 by 8. Now if we write sum of all probabilities, it will be 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, which is 1. Now this table is called as probability distribution of random variable x. And the same way we can find probability distribution for this y. So we have yn, py. Now y can take two values, 1 and 3. Now probability of getting 1, it is 6 by 8, and probability of getting y equals 3 is 2 by 8, and again this sum of all probabilities is 1. So this is how we define a probability distribution. So for any random experiment, we'll define a random variable, and for that random variable, we'll create this table with x and px, and we're going to write values of random variable with their corresponding probabilities. Say x1, x2, x3 up to xn, and their probabilities are px1, px2, px3 up to pxn. Now, once we have defined a probability distribution, we can find mean and variance of a random variable. So the first thing that we can define is its mean or average value, or we can say mathematical expectation of a random variable. Mathematical expectation of random variable. Now basically we'll write this mean as mu or ex, which is expectation of this random variable x. Now expectation of this random variable x is this summation xi into pxi over all I. So all we need to do is we just need to multiply every random variable with its corresponding probability, and then we'll add them all up to get mean or expected value of a random variable. And the second thing that we'll study is variance of a random variable. Now, variance of random variable, we can write it as sigma x square, or simply variance of x, and variance of x is actually expectation of x minus mu square. So if mu is mean of random variable, then its variance is expectation of x minus mu square, which is basically this summation xi minus mu square into pxi over all I. So if we have to find its variance, one of the method is make another column which is xi minus mu square, and then write corresponding entries x1 minus mu square, x2 minus mu square, and xn minus mu square, and simply multiply it with its probability and add them to find variance of this random variable. Now if you want, we can simplify this expression. So we can write this as this summation xi square into pxi minus 2 mu xi into pxi plus mu square into pxi. Now we can simplify this summation. We can write this as this summation over all I xi square into pxi minus 2 mu summation xi into pxi and plus mu square into this summation pxi. Now this is summation xi square into pxi minus 2 this summation xi into pxi is mu again. So it will be mu square and plus, now summation pxi is 1. So it will be this mu square. So another method to write variance of random variable is simply by taking this summation xi square into pxi and then minus mu square. So either we can calculate this variance using this formula where we'll add this term in the table xi minus mu square and then multiply it with pxi and then add them, or another way is rather than adding xi minus mu square, we simply add xi square. So it will be this x1 square, x2 square and xn square, and then we'll find summation xi square into pxi, and once we get this result, from this result we'll subtract mu square to get its variance. So these are the two methods to calculate variance of a random variable. Now we'll come back to our probability distributions to calculate their mean and variance. Now first we'll consider mean of this probability distribution. Now in this case we can write this mu or ex as summation xi into pxi over all I. Now here value of x is 0, corresponding probability is 1 by 8, so it will be 0 into 1 by 8 plus, now this is 1 into 3 by 8 plus 2 into 3 by 8 and plus 3 into 1 by 8, which is 12 by 8. So in this case, mean of random variable is 3 by 2. Now once we have this mean, we have to calculate its variance. Now we'll calculate its variance in two ways. Now here value of mu is 3 by 2, so we'll make this table x minus mu square. Now this is 0 minus 3 by 2 square, so it will be 9 by 4. 1 minus 3 by 2 is minus 1 by 2. Minus 1 by 2 square is 1 by 4. Now 2 minus 3 by 2 is 1 by 2. 1 by 2 square is again 1 by 4. And 3 minus 3 by 2 is 3 by 2. And 3 by 2 square is 9 by 4. So in this case, variance of x is x minus mu square into px. So it will be 9 by 4 into 1 by 8. So it will be 9 by 4 into 1 by 8 plus 1 by 4 into 3 by 8 plus 1 by 4 into 3 by 8 plus 9 by 4 into 1 by 8, and this is 24 upon 32, which is 3 by 4. So for this random variable x, mean is 3 by 2. So average or expected value of random variable in this random experiment is 3 by 2 and its variance is 3 by 4. And with variance, we can also calculate its standard deviation. Now we know that standard deviation is under root of variance x. Now we know that standard deviation is under root of variance. So in this case, the standard deviation of random variable x will be under root of 3 by 4 or simply root 3 by 2. We can calculate this variance using other formula. And for this other formula, we take x square. So in this table, rather than taking this, we'll take simply x square. Now here 0 square is 0, 1 square is 1, 2 square is 4 and 3 square is 9. So if we find summation xi square into pxi, it will be 0 into 1 by 8 plus 1 into 3 by 8 plus 4 into 3 by 8, 9 into 1 by 8. Now this value is 12 and 12, 24. So it will be 24 by 8, which is 3. Now once we have this value, we can write variance of x as sigma xi square into pxi minus mu square. Now this summation is 3 minus mu square is 9 by 4, which again is 3 by 4. So we'll get the same value. So we can use this method where we use x minus mu square, or we can use this method where we use x square. So if the value of mean is complicated, then it's better to use x square. And if mean is simple, then we can simply use x minus mu square. This is how we define a random variable. And for that random variable, we can create a probability distribution. And from that distribution, we can work out its mean, variance, and standard deviation. Now we'll find mean and variance of random variable y. Now in this case, mu is 1 into 6 by 8 plus 3 into 2 by 8, and there will be 12 by 8, which is 3 by 2. Now for variance, we can use either one. So here I'll take this y square. So it will be this y square, and y square is 1 and 9. So if we calculate summation yi square into pyi, it will be 6 by 8 plus 18 by 8, which is 24 by 8, and 24 by 8 is 3. And in this case, variance of y is this summation yi square into pyi minus mu square, which is 3 minus mu square, and that is 9 by 4, and it will be 3 by 4. Now we'll find mean and variance for this second random experiment A2 for this random variable x. Now we'll draw its probability distribution. So it will be this 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, and 2. So this is x and this is px, and we'll also need one more column for variance. Now this sum, it can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now sum is 2. This probability is 1 by 36 because sum is 2 if and only if both the numbers are 1. So this probability is 1 by 36. Now sum is 3. We'll have 3 with 1, 2 and 2, 1. So it will be 2 by 36. Now 4 is 1, 3, 2, 2 and 3, 1. So it will be 3 by 36. Now 5 will be 4 by 36. 6 will be 5 by 36. 7 will be 6 by 36. And 8 again will be 5 by 36. 9 is 4 by 36. 10 is 3 by 36. 11 is 2 by 36 and 12 is 1 by 36. Now once we have x and px, we can calculate its average value or its expected value. So mathematical expectation of x will be, we'll take this 1 by 36 common from each, and then we'll have 2 plus 6 plus 12 plus 20 plus 30 plus 42 plus 40 plus 36 plus 30 plus 22 and plus 12, which is 252 divided by 36, which is 7. So average value of this random variable x is 7. Now if we draw this probability distribution, it has values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Value at 2 is 1 by 36 and 12 is 1 by 36. 3 is 2 by 36. 11 is 2 by 36. 4 is 3 by 36. Here also it is 3 by 36. 4 by 36. 4 by 36. This is 5 by 36. 5 by 36. And at 7 it is 6 by 36. So this distribution, it is symmetrical about this number 7. So its mean, it should be 7. So this value 7, it is expected as mean of this random variable. Now we'll find its variance. For this one, we'll use x minus mu square, and mu in this case is 7. So we'll write x minus 7 square. Now 2 minus 7 is 5. So it'll be this 5 square, 4 square, 3 square, 2 square, 1 square, 0, 1 square, 2 square, 3 square, 4 square and 5 square. Now once we have these two, we can directly write variance of this random variable x. Now in this case, variance of x will be, now again we'll take 1 by 36 common, and here this is 5 square into 1, 4 square into 2, 3 square into 3, 4 into 4, 5 into 1, plus 0, and again this is 1 into 5, 4 into 4, 9 into 3, and 5 square into 1. So all we have to do is we have to multiply it with 2. Now this is 1 by 36 into 105 into 2. Now this is 80. If we solve this value, it will be 5.83. So mean of random variable is 7 and its variance is 5.83. Now there will be situations where this random variable, it may have continuous values. So for continuous random variable, say x, we define this function, say fx, from r to 0 to infinite, and we call this function fx as probability density function, and this fx will be probability density function if this integral from minus infinite to plus infinite fx dx, it is equal to 1. So for the continuous random variables, we are defining a function which is called as probability density function, and here value of fx, it must be greater than or equal to 0. Now for probability density function, the probability that random variable x lies between a and b, it is given by this integral from a to b fx dx. So this probability will be given by this area under the curve from x equal to a to x equals b. Now for continuous random variables, we can define its mean mu or ex as this integral from minus infinite to plus infinite x into fx dx, and its variance, it will be this integral from minus infinite to plus infinite x minus mu square into fx dx. So we can define probability distributions not just for discrete random variables, we can define them for continuous random variables also. Now let us take up an example. Say for example, it says we are given a continuous random variable x, which is defined by this probability density function fx, which is kx cubed when x lies between 0 and 1 and it is 0 otherwise. Now here the question is, find the value of k, mean of probability distribution and variance of probability distribution. Now first thing is, if this is probability distribution, then this integral from minus infinite to plus infinite fx dx, it must be equal to 1. Now this definition is 0 for all of the interval. So if we integrate this function, this integral will be from 0 to 1. Now fx dx is kx cubed dx and it is equal to 1. So here we'll get this k and it is x to the power 4 upon 4 from 0 to 1, it is 1. So value of k, it must be 4. So if this is probability distribution, then value of k in this case is 4. So now we have value of k. Now with this value of k, we can find its mean. Mean of this probability distribution, it will be this integral from minus infinite to plus infinite x fx dx. Now this integral will be 0 except for the region between 0 and 1. So it will be this integral from 0 to 1 x, and fx in this case is 4x cubed. So it will be 4 into this integral from 0 to 1 x to the power 4 dx, and it will be equal to 4 into x to the power 5 upon 5 from 0 to 1. So its mean will be simply 4 by 5. Now we'll calculate its variance. Its variance will be this integral from minus infinite to plus infinite x minus mu, and mu in this case is 4 by 5. So it will be x minus 4 by 5 whole square into fx dx. So again this integral will be from 0 to 1 and then x minus 4 by 5 square, and fx is 4x cubed dx. So it will be this integral from 0 to 1, and this is x square plus 16 by 25 minus 8x by 5, and we'll take this 4 common, and it will be this x cubed dx, or we can write this 4 into this integral from 0 to 1, and this is x to the power 5 plus 16 upon 25 x cubed minus 8 by 5 x to the power 4 into dx. Now this value will be x to the power 6 upon 6 plus 16 upon 25 x to the power 4 upon 4 minus 8 by 5 x to the power 5 upon 5 from 0 to 1, which is 4 into 1 by 6 plus 4 by 25 minus 8 by 25, which is 4 into 1 by 6 minus 4 by 25. So this is 4 and this is 25. 25 minus 24 is 1, and this is 6 into 25. This is 3 and 2. So its variance is 2 by 75. And another method to calculate variance for the same question is, we can write this variance of x as this integral from minus infinite to plus infinite x square fx dx minus mu square. So it will be this integral. Now again fx is defined between 0 and 1. So it will be this integral from 0 to 1 x square into 4x cubed dx minus and mu square. And mu square in this case is 4 by 5 square. Now this is 4 and it is x to the power 5. X to the power 5 is x to the power 6 upon 6 from 0 to 1 minus 16 upon 25. So this value is 2 by 3 minus 16 upon 25. Now this is 50, 50 minus 48 is 2, and here this is 75. So again we'll get this answer as 2 by 75. So variance of this function is 2 by 75. Now here the question is, a person throws 2 fair dice. He wins rupees 15 for throwing a doublet, wins 12 when he throws a result in the sum of 9, and loses 6 for any other outcome of the throw. We need to find expected gain or loss of this person. So here we have 3 values for random variable. So either it will be plus 15 or plus 12, or it will be this minus 6. Now what are their probabilities? Now he'll get 15 when he throws a doublet, and this probability is 6 by 36. Now he'll get rupees 12 if the sum is 9. So it'll be 9 if it is 3, 6, 4, 5, 5, 4 and 6, 3, which is 4 by 36, and all other cases it is minus 6. So it'll be this 10 by 36. 1 minus 10 by 36 is 26 by 36. Now expected value of x will be 15 into 3 plus 12 into 2 minus 6 into 13 whole divided by 18, which is minus 1 by 2. So the expected gain of this person is minus 1 by 2 loss. Now here the question is, in a game, man wins 100 if he gets 5 or 6 on a throw of fair die, and loses 50 for getting any other number on the die. If he decides to throw the die either till he gets a 5 or a 6 or to a maximum of 3 throws, then his expected gain or loss in rupees is. Now probability of his winning is only if he gets 5 or 6. So this probability is 2 by 6, which is 1 by 3, and probability of him losing on any chances 2 by 3. Now this game continues if he gets P, or if it is QP, or if it is QQP, or if it is Q, Q and Q. Now in this case, value of a random variable will be, if he wins, it will be 100. So it will be this 100. Now there is a loss and a win. So it will be 100 minus 50. So it will be plus 50. Now 2 losses and 1 win. So value of x is 0. And then 3 losses will be minus 150. And their respective probabilities, they are 1 by 3. Now this is 2 by 9. This is 4 by 27. And this is 8 by 27. So expected value of this random variable x will be 100 by 3 plus 100 by 9 minus 1200 by 27. Now this is 900 by 27 plus 300 by 27 minus 1200 by 27, which is 0. So expected value is 0. No gain, no loss. Now here the question is, in a game of chance, each player throws 2 unbiased dice and scores the difference between the larger and smaller number which arise. 2 players compete and one or the other wins if and only if he scores at least 4 more than his opponent. Find the probability that neither player wins. Now, if we throw a pair of dice, then in that case, the difference that we can have between the 2 dice are 0, 1, 2, 3, 4 and 5. So these are the possible differences between the 2 dice. And we can also find their respective probabilities. Now the difference is 0 when all the numbers are same. So in this case, it will be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So this probability will be 6 by 36. Now difference between the 2 numbers, it is 1. Now the difference is 1 if we have 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6, and the reverse order. So we'll have 10. So it'll be simply 10 by 36. Now if the difference is 2, then we have 1, 3, 2, 4, 3, 5, and 4, 6, 2 times again. So it'll be 8 by 36. Difference of 3. So it'll be 1, 4, 2, 5, and 3, 6 into 2, which again is 6 by 36. Difference of 4. 1, 5, 2, 6 into 2. So that'll be 4 by 36. And difference of 5 will be simply 1, 6 and 6, 1. So that'll be 2 by 36. Now it says 2 players compete and one or the other wins if and only if he scores at least 4 or more points than his opponent. Find the probability that neither player wins. What we'll do is we'll find the probability that one of them actually wins the match. So the person is going to win if there is a margin of at least 4. So it can be either 0.4, 0.5 and 1.5. So these are the only 3 cases possible. So this required probability will be 2 times, because it can be 0.4 or 4.0, 5.0 or 0.5, or 1.5 and 5.1. So 2 times into the probability of getting 0 and 4. There will be 6 by 36 into 4 by 36. So it will be 24 by 36 square plus 0.5. 0.5 will be 12 by 36 square and plus 1.5, and 1.5 will be 20 by 36 square. Now 24 plus 12 is 36. 36 square upon 36 is 1 by 36. So it will be 1 by 36 plus, and here will be 5 36 into 9. So we can write this as 2 by 36, and this is 9 plus 5, 14. 14 by 9. Now this is 2, and this is 7, and this is 9. So it will be simply 7 by 81. Now we need to find the probability that neither of them wins the match. So it will be this probability of W0, and that will be 1 minus 7 by 81, and that will be simply 74 by 81, and that is the answer to this question. Now question number 19 is, let x1, x2 and xn be independent and identically distributed with pxi equals 1 equals pxi equals minus 1 equals p, and then pxi equals 0 as 1 minus 2p for all I from 1 to n. Then we have defined an as this probability x1, x2, xn is equal to 1. Second one is bn, which is x1, x2, xn as minus 1, and this third one where x1, x2 into xn, it is equal to 0, and we have taken it as cn. So for any random variable xi, there are 3 choices. Either it will be 1, 0 or minus 1, and their corresponding probabilities are p, 1 minus 2p and p. Now since it represents a binomial distribution, 1 minus 2p should be greater than 0, that is value of p should be less than 1 by 2. Now first we'll talk about an. Now an is this probability x1, x2 into xn, and it is equal to 1. Now first we need to find in how many ways we can choose x1, x2 and xn such that its product is 1. Now one of the way of choosing it is when all the values they are 1. So if all the values they are 1, then we have only one case. Next one could be when n minus 2 values are 1 and then 2 values are minus 1. Then again their product will be 1. So from these n, we need to select 2 which will have the value minus 1. So it will be simply nc2. Next one will be all ones except 4 minus 1s. Here it will be simply NC4. It will continue till we have maximum number of minus 1s possible. Now since all these distributions, they are independent, then we know that in any scenario px1 x2 into xn will be px1 into px2 into pxn will be simply p into p n times, because for plus 1 this probability is p and minus 1 also this probability is p. For each of these conditions this probability will be p into p n times, and that should be p to the power n. So now we can write an. So this an will be, now this first one it is nc0 p to the power n. Second one will be nc2 p to the power n, nc4 p to the power n. So we'll get this condition as nc0 plus nc2 plus nc4 into p to the power n. Now we know that the value of this binomial series is 2 to the power of n minus 1. So it will be 2 to the power of n minus 1 into p to the power n. So it will be 1 by 2 into 2p to the power n. Now we'll take this limit n tends to infinite an will be 1 by 2 and then 2p to the power n. Now 2p is less than 1. So if 2p is less than 1, then 2p to the power infinite will be simply 0. So value of an, it tends to 0. Now in the same way, we can prove the result for bn. So for bn, we'll start with minus 1, and then we'll replace minus 1s with plus 1s. So we'll again end up getting the same expression. So from symmetry, we can say this bn tends to 0. So an tends to 0 and bn tends to 0. Now we know that either this product will be plus 1, or this product will be minus 1, or this product will be 0. That means sum of an plus bn plus cn will be 1. Now limiting value of an and bn, it is already 0. So from here we can say limiting value of cn will then be 1. So answer to this question will be an tends to 0, bn tends to 0 and cn tends to 1, and that's your option number D. Now the question is, there are 4 boxes A1, A2, A3 and A4. Box AI has I cards and on each card a number is printed. The numbers are from 1 to I. A box is selected randomly. The probability of selection of box AI is I by 10 and then a card is drawn. Now let EI represent the event that a card with number I is drawn. Now first one is, we need to find this probability of E1. Now probability of E1 is that card with number 1 is drawn. Now this card, it can come from any box. So it will be this PAI and then probability of E1 upon AI for I varies from 1 to 4. So it will be this summation I varies from 1 to 4. Now probability of choosing AI is simply I by 10 and probability of getting 1 from AI is simply 1 by I. So this probability is simply 1 by 10. So it will be 1 by 10, 1 by 10, 1 by 10 4 times. So there will be 4 by 10, which is 2 by 5, option C. Now the second part is, if the number chosen is 2, then find the probability that it has come from A3. Now probability of choosing E2 will be this summation I varies from 1 to 4, probability of choosing AI into probability of choosing E2 upon AI. Now in the first box there is only one card and which is 1, so we cannot get anything from this first box. So this first probability will be 0. So now we are left with this probability, that probability of A2, probability of E2 upon A2, probability of A3, probability of E2 upon A3 and probability of A4, probability of E2 upon A4. Now this is 2 by 10 into 1 by 2. this is 3 by 10 into 1 by 3, and this is 4 by 10 into 1 by 4. So this probability is 3 by 10. Now we need to find this probability that if the card is E2, it has come from this third box. So we'll take this case in the numerator. So it will be this 1 by 10 divided by 3 by 10, which is 1 by 3, and that's your option B. Now the next one is find the expectation of number on the card. Now number on the card, it could be either 1 or 2 or 3 or 4 and their corresponding probabilities. Now if the number is 1, this probability is 2 by 5 or simply 4 by 10. Now for E2, it is 3 by 10. Now for this number to be 3, it will be 2 by 10, and for 4, it will be simply 1 by 10. Now if we have to find mean of random variable Ex, which is mu, it will be this 4 by 10 plus 6 by 10 plus 6 by 10 plus 4 by 10, which is 2. So the expected value of the number on the cards is 2, and that's your option A.